simplify each expression. So for part A, we have 4 minus 5i plus 7 plus 8i. So for anything like this, you add the real bits and the imaginary bits separately. So the real part of a complex number, well, in this case, the 4 is real and the minus 5 is imaginary. So we have 4 minus 5i plus 7 plus 8i. So those brackets aren't doing anything other than to indicate that we've got two separate complex numbers that we're adding. So then we just literally treat the real and the imaginary part separately, and you're just collecting like terms. 4 plus 7 is 11. Minus 5 plus 8 is plus 3, so plus 3i. 11 plus 3i is the result of that. Part B, 4 minus 5i minus 7 plus 8i. So now we have 4 minus 5i minus 7 plus 8i. That's how I'm sure you could do this without writing this next line, but I'm going to do it anyway, given that it's an example. So I'm going to say this equals 4 minus 5i minus 7 minus 8i. Just group the real bits together. So 4 minus 7 is minus 3. And then the imaginary parts, you've got minus 5 minus 8, so minus 13i. And I suppose you could pull a minus sign out of that, but I'm not going to. Part C. Now we need to multiply. So you have 4 minus 5i, 7 plus 8i. Okay, so it's just FOIL. You just multiply the brackets as you normally would. So you've got 4 times 7 equals 28. Then you've got 4 times 8i is plus 32i. Then you've got minus 5i times 7, which is minus 35i. And the last bit is minus 5 times 8, which is minus 40. And you've got I times I, which is I squared. So this is when it gets a bit tricky. The first 3 terms are absolutely fine. Then you've got to deal with the I squared. So remember, the whole of the complex number system is built around one key principle, which is that I squared equals minus 1. So I equals the square root of minus 1. So this now turns into, well, you've got 28. You've got 32 minus 35 is minus 3i. Then you've got minus 40 times minus 1. So minus 40, I squared is minus 1. So that's going to end up being plus 40. 28 plus 40 is 68. So it equals 68 minus 3i. Remember, I squared equals minus 1. Just to show you how you can do this on your calculator, you need to make sure that you are in a complex mode. So on the setup, go down a bit, make sure you're in complex mode, as in a plus bi. The default would be real. You just need to make sure it says a plus bi. So if we do part A, 4, we should be able to type in exactly as it looks. So you have 4 minus 5i. So you can see an I just down here. So shift I. And we're plus 7 plus 8i plus 7 plus 8. I over here. So that gives us 11 plus 3i. For part B, 4 minus 5i minus 7 plus 8i. 4 minus 5i minus 7 plus 8i. 7 plus 8i, like that. And that gives us our minus 3 minus 13i. For part C, where we multiply 4 minus 5i. 4 minus 5i times by 7 plus 8i. 7 plus 8i. And that gives us 68 minus 3i. So you can do these basic calculations with a calculator. For something like this, you shouldn't really need to, and it's very unlikely that these sort of operations would appear in a calculator setting. But if you're involved, it could be that you're doing things where you end up with answers to three significant figures, in which case you need to know how to put your calculator into the complex mode and how to find the I and so on.